Hi students, now we are going to solve the fifth numerical problem. 2 point charges QA equal to 3 microcoulomb and QB equal to minus 3 microcoulomb are located 20 centimeter apart in vacuum. At points A and B, 2 charges are located. So this is plus 3 microcoulomb, this is minus 3 microcoulomb. They are separated by distance total 20 centimeter. So I have located O is the midpoint of the straight line, so that the distance is divided from the midpoint as 10 centimeter each from A and B. Now subdivision A, what is the electric field at the midpoint O of the line AB joining the 2 charges? So what will be the electric field at this point O? We have to find out. B, if a negative test charge of magnitude 1.5 into 10 power minus 9 coulomb is placed at this point O, what is the force experienced by the test charge? This is a very important and interesting problem which is repeatedly asked in many competitive exams as well as in the CBSE board exam. Now for the subdivision A, you look at the charges located at A and B. There are 2 charges and the straight line joins A and B. O is the midpoint. Now at this point O, there will be 2 electric fields. There will be 2 electric fields. One due to this positive charge and the other one due to this negative charge. So there are 2 electric fields at this point O. Okay children, now you tell me, if you want to measure the electric field intensity at any point, you have to place a test charge of plus 1 coulomb. That is called unit positive charge. So I am going to place here plus 1 coulomb. This is a positive charge of 1 coulomb. Okay. Will this positive charge experience a repulsive force due to this positive charge of 3 microcoulomb or not? Yes, sir. So this is positive charge and this also is a positive charge of plus 3 into 10 power minus 3 coulomb. So it will be repelled. So this point charge will be repelled towards the point B. So I will take this is the direction of electric field intensity due to the charge placed at A. So the direction of the electric field at this point O due to the charge placed at A is towards OB. Understand? Okay. At the same time, this unit positive charge will also experience another force, is it not? Due to the second charge located at B. What kind of charge is placed at B? It is a negative charge. So that negative charge will try to pull the positive charge of plus 1 coulomb towards B itself. So at the same point O, on the same charge plus 1 coulomb, there is another force which is acting along the direction OB. That is the direction of the electric field at O due to the second charge. Normally the students will mistake that the net electric field at the midpoint will be 0 because 2 charges are equal and opposite. That is wrong. Is it not? So if you want to measure the electric field intensity at the midpoint O, first what is the requirement? You have to place a unit positive charge, a test charge of plus 1 coulomb. And this charge at O will experience 2 forces. One is repulsive force from A, that is towards OB. The other one is attractive force towards B, that also is O to B. So these 2, that is the direction of the electric field EA due to the first charge and EB due to the second charge, both are in the same direction. So we have to find the net electric field at the midpoint O by adding EA and EB. Okay students, first I will find out this electric field intensity or the magnitude of the electric field at O due to the charge located at A, that is EA. So by formula this is equal to 1 by 4 pi epsilon naught, because it is in vacuum. Epsilon naught I have to substitute into the given charge is what? Okay, magnitude of the charge is 3 into 10 power minus 6 divided by distance square. This is 10 centimeter the whole square, is it not? So this distance I will write here r square. This unit is Newton per Coulomb. So Q by r square. So here r is equal to what? R is equal to 10 centimeter. So 10 centimeter is also equal to what? 0.1 meter. I am substituting in meter. So EA is now equal to what? EA is now equal to this constant is 9 into 10 to the power of 9 into 3, okay, into 10 to the power of minus 6 whole divided by r square is 10 power. This is 0.1 meter. 0.1 meter also is equal to what? 10 power minus 1 meter. Make it short. It will be easy for you to understand. So 10 power minus 1 whole square is directly I am writing 10 power minus 2. Understand? Okay children, now you see that 10 power minus 2 is coming up. Okay, it will become 10 power plus 2. So that this is equal to, so this is equal to 9 into 10 to the power of 9 plus 2 is 11. Okay, 11 into 3 into 10 to the power of minus 6. Therefore EA is now equal to 9 into 3 is 27. Okay, so this is 27 into 11 minus 6 is 5. That is this is 10 power 11 minus 6 is 10 power 5 Newton per Coulomb. Okay, if you want you can write this also as what? 2.7 into 10 to the power of 6 Newton per Coulomb. Because normally this will be less than 10 only according to the rules of dimensional formula. So this is 2.7 into 10 power 6 Newton per Coulomb is our wish. You can write as it is also, no problem. Okay, similarly now the same charge is going to experience another force and the electric field at O due to the second charge, that is given by what? E suffix B. So this is 9 into 10 to the power of 9 into this charge, okay, is also having the same magnitude. Magnitude is the same. So only magnitude I have to substitute. So this is also what? 3 into 10 power minus 6 whole divided by what? 10 power minus 2. Same value only is going to come. Magnitude is the same. So EB is also is equal to what? 2.7 multiplied by 10 power 6 Newton per Coulomb. Therefore, the net field, okay, the net electric field at O is E is equal to, both are in the same direction. Can you see that? EA also is acting from O towards B. EB is also acting from O towards B. So we have to add these two, is it not? So this is EA plus EB and this is equal to 2.7 plus 2.7, common factor is 10 power 6. So this is equal to 5.4, okay, into 10 power 6 Newton per Coulomb. This is the net electric field at O. So the resultant electric field at O due to these two charges is found to be what? E is equal to 5.4 into 10 power 6 Newton per Coulomb. Okay, what is the second subdivision? If a negative test charge, so here this is point A, this is O midpoint and this is point B. Here there is a charge of 3 microcoulomb and here there is a charge of minus 3 microcoulomb. Instead of a unit positive charge plus 1 coulomb, if you keep a negative charge, a negative test charge of 1.5 into 10 power minus 9 coulomb. So this is minus 1.5 into 10 power minus 9 coulomb. So what force it is going to experience? I am going to take this is this charge is equal to what? Q is equal to 1.5 into 10 power minus 9 coulomb. So here there is a relation that is F, force experienced is equal to the charge Q into electric field. The force experienced, because electric field intensity, because what? Because electric field intensity is equal to force per unit charge. We have studied in the theory class, is it not? The force experienced per unit charge, Newton per Coulomb, is the electric field. Therefore, what is F is equal to E into Q or Q into E. Okay, so what force it is going to experience? Therefore, F is equal to Q. Q is how much? 1.5 into 10 to the power of minus 9 multiplied by the electric field intensity is what? 5.4. So this is 5.4 into 10 to the power of plus 6. So that if you multiply this means it will be equal to 8.1 into, this is plus 6, this is minus 9. So that this will be what? Minus 3. Therefore, the force experienced by the charge is 8.1 into 10 to the power of minus 3 Newton. This is the answer. Okay, students. So, first thing is, you should not misunderstand that at the midpoint, the electric field due to two equal and opposite charges is 0. That is a misunderstanding. You have to understand that if you want to find the electric field at any point means you have to place a test charge of plus 1 Coulomb. This is called unit positive charge, and it will experience two forces. Understand? So the net field is due to the field due to the first charge and the field due to the second charge. Both will be in the same direction. So instead of unit positive charge, if you keep any other charge means use directly this equation, F is equal to QE. Understand? I hope you have understood well. Fine.